Hi everyone, welcome back once again. Today we're gonna continue with our November 2021 paper 2 revision, and today we're gonna look at question 11, which is your Euclidean geometry. Question 11, 11.2, we are given in the diagram PK, so we have P there. PK is a tangent to a circle at K, and chord LS is produced. P and M are the points on KP and SP respectively, such that MN is parallel to SK, and they've just represented using the symbol of parallel lines there in the diagram. We are given chord KS and LN intersect at T. All right. So 11.2.1, they want us to prove, given reasons, that angle K4A, it is that angle K4, this angle there, is equals to angle MNL. It's that angle there. All right. So they want us to prove. How do we prove that angles are equal? There's a very, very simple, straightforward method. What you do is you go and check what each angle is equals to, right? So you go and check your K4 alone to say what is K4 equals to, right? Using your Euclidean geometry theorems, right? And you go and again check what is my MNL equals to. What is that angle equals to? You'll find that they are actually equals to the same thing. Therefore, you can conclude they are also equal to each other. Okay, so we are going to check K4 first to say what is my angle K4 equals to using Euclidean geometry theorem. Okay, let's take a look at K4, right? So our angle K4, it's actually an angle between a chord and a tangent. Can you see? It's a chord and a tangent. What do we can think of what? Tan chord theorem that says that the angle between the tangent and the chord is actually equals to what? The angle subtended by the two other chords on the what? On the circumference. Okay, meaning that we can say angle K4 is actually equals to what? Is actually equals to angle S1, right? By what? By tan chord theorem. Okay, we know that from tan chord, angle between tangent and the chord is equals to the angle subtended by the two other chords on the circumference, and this is our tan chord theorem. Okay, so let's go and check what is our angle MNL equals to, right? Let's go and check this. Okay, so angle NML, can we see this is an angle here, and they are parallel lines. Can we see this line is parallel to this one? We can think of what? Of corresponding angles. Sorry about that. We can think of corresponding angles to say our angle MNL is actually also equals to S1 by corresponding angles, right? By corresponding angles, and you also give them the lines that are parallel, because we are given MN is parallel to what? To SK. Can you see now? Now we can now conclude that actually this K4, angle K4, will also be equals to angle what? MNL, right? Because both of them are equals to what? Angle S1. All right. Therefore, we have proven that indeed K4 is equals to angle NML. Okay. B, they want us to prove with given reasons that KLMN is a cyclic quad. It only have one mark, right? So it's a corresponding, it's a follow-up question after A. Let's go and check this KLM. We have K there, K there, L there, M there, and N there. So they want us to prove that that quad is actually a cyclic quad. How can we prove that, right? We have just proven that angle K4 is actually equals to what? Is actually equals to angle MNM. And you can see that that is an exterior angle of a quad, right? Is equals to the opposite to what? Interior angle. Therefore, we can simply say, oh, actually, K4 is equals to NML, right? Why? We have proven it above, right? We've just proven it above that angle K4, which is the exterior angle, is equals to what? NML, right? We have proven it above. Therefore, we can conclude that actually KLMN is what? Is cyclic quad. Why? Because exterior angle is equals to opposite interior angle. We can see that exterior angle of that quad is actually equals to the opposite interior angle. Hence, we can conclude that is a cyclic quad. All right, 11.2.2. They want us to prove given reasons that triangle LKN. Let me just highlight it for you. LKN. It's this triangle there. All right. It's actually similar to what? KSM. KSM is this triangle there. All right. So they want us to prove that the two triangles are what? Are similar. Or maybe to avoid confusion, let me just use a different color for this. KSM. All right. They want us to prove that they are similar. Okay, so the first step we're going to say, let me use a black color, 11.2.2, in triangle what? LKN and what? And triangle KSM. We are going to identify two triangles that are equal between the two triangles. Then we know that it's not important to identify the third one because of third angle of a triangle. We know that obviously the third one, if two of them are equal, then the third one will be equal, right? So simply you just identify two angles that are equal between the two triangles. Okay, remember we have just proven in the previous question that there is a circle, there's a quad, there's another circle, right? There's another quad inside a circle. We have proven that KLMN is a cyclic quad, right? Let me just show you again. I can just show a circle between these points, KLMN, right? We've just proven that it's also what? It's a cyclic quad, right? Although my circle doesn't look like a circle, but it's something like that, right? So we can also use knowledge or properties about cyclic quad in order to answer this question, because we have proven that it's a cyclic quad in the previous question. So they also want you to incorporate this knowledge to see how you can prove this. Okay, so basically let's go and check something here. It seems like we have an oxbow, right? We have an oxbow, and let's see the angle that this oxbow subtends, right? We can see, take a look at the chord LN, right, or arc LN in the red circle, right? There's a chord LN. It's subtending an angle at the circumference, which is what? Which is angle N3. Can you see angle N3? The same chord, let me show you this angle properly because this diagram is quite complicated. N3 there, right? The same chord LN is subtending another angle, right, at another circumference. Can you see? Can you see here? Okay, I hope you can see because there's just different colors here. But look at this. It's also subtending another angle at the circumference, right? Which is what? M3, meaning that we can say angle M3 and angle M3 are what? Are equal by what? Angles at same segment. Okay, these are angles at the same segment, right? So we have just shown you that the same chord is subtending an angle at the circumference M3, the same one subtending another angle at the circumference, which is what? Which is M3, meaning that they're equal. It's like angles in the oxbow. This one is equals to this one because we have proven that that thing is a cyclic quad. Okay, so that's how we got the first one. Let's go to the second one. All right, let's go and get the second angle. I am very aware that this place is now a mess. Oh, our diagram here. Let's just delete some of the things. All right, let's go and look for another angle. Remember, we've just proven that N3, right? Let me show you again. N3 is equals to what? Is equals to M3, because those are angles at the same segment, right? Inside that oxbow, right? And now let's go and check another one. So we look at other angles now. Okay, so let's check this one in the triangle NKL, 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 that angle, right? So that angle NKL is actually an exterior opposite angle to this one. Can you see? Because we have proven this is a cyclic quad. Remember, that one is a cyclic quad, KLMN, right? That's why I just show you with a red that there's a circle there, meaning that we can say the exterior angle M1 will be equals to the opposite interior angle, right? Which will be equals to what? Angle NKL, right? Meaning that angle NKL will be equals to angle what? Angle M1, right? By what? Exterior angle of what? Of cyclic quad, right? But now this angle is not equals to any angle inside the triangle. It's actually equals to some angle outside, right? Let's go and look what is our angle M1 equals to now, right? Look at something interesting now. They are parallel lines. This line is parallel to which one? To that one. Meaning that, look at this. We can now come and deduce that actually our M1, this M1, is also equals to angle what? Angle S2. By what? Corresponding angles. And we show them the lines that are parallel because MN is parallel to SK. So they won't give you something that is clearly obvious to say this angle is equal to this angle equals to this, then you conclude they are similar. No, sometimes you'll have to go the long way. You just need to check, okay, because now I've proven that N3 is equals to M3. Let me go and check the other ones that are remaining. We are remaining with this angle K. What is it equal to? Now you recall the properties. Oh, there's actually an exterior angle, so basically we say exterior angle of a cyclic quad is equals to what? Opposite interior angle. Remember that one is a cyclic quad, right? We have proven it above, so they want you to connect this knowledge to be able to prove that. Okay, so then after getting your two angles that are equal, remember you have proven that angle N3, right? Let me just show you because our diagram is now quite complicated. So we have proven that angle N3 is equals to angle M3, right, between the two triangles, yellow and blue triangle, this triangle that we needed to prove similarity. This one is equals to this one, right, because those are angles at the same segment. Then we also proven that actually this big angle, the NKL, is also equals to this angle there, right, S2. And it was in an easy approach we had to use that long method to say actually it's equal to an exterior angle, then this exterior is equals to S2 by corresponding angles. Okay, so after getting two angles that are equal, you don't have to look for the third one. We know it's equal by third angle. You don't need to write that. You can write that if you want, but after getting the two, you can just simply conclude therefore triangle ACAN is similar to triangle what? KSM by what? Angle. All right. Okay, let's now go to 11.2.3. It says that if LK is equals to 12 units and 3KN is equals to 4SM, determine the length of KS. Determine the length of what? KS. So basically, after a question that required you to prove similarity, you have to be thinking in your mind proportionality, right? Because there's a theorem in your grade 12 that you did, and we also did it in one of our sessions to say from similarity we move to proportionality. Okay, so obviously after proving similarity you can go to proportionality and try to answer this next question. There will always be that relational understanding approach to say whatever question that comes after similarity, I want you to connect with that similarity you have proven above. Okay, so we have just proven that in the previous question LKN is similar to KSM. Now they want us to calculate KS, and you can see KS is one of the length that is in our similarity, meaning that we have to go to what? To proportionality. How do we go to proportionality? Because triangle LKN is similar to triangle KSM. We can now move to proportionality. And how do we go this? We have covered it in quite a number of sessions. We'll say LK divided by what? KS will be equals to what? KN divided by what? By SM, which will be equals to what? LN, the last ones, and what? And KM. Okay, so why are we saying they're equal? Because triangle LKN is similar to triangle KSM. We know that from similarity we move to what? To proportionality. Okay, so now let's go and substitute whatever we have. We have LK, which is 12, right? We are also given that 3KN, all right? This KN is equals to what? 4SM, right? Meaning that we can solve for KM to say 3KM is equals to 4SM. If we solve for KN, it will be what? We divide by 3, right? We divide by 3, both sides. Okay, this cancel this. Then KN will be equals to 4 over 3. Let me write it on top. KN will be 4 over 3 SM. Okay, so we are given all those things and they want us to determine KS. Okay, so meaning this proportionality won't be useful, the last one, because we only have LK. We want to solve for KS, KN, and SM are also given, meaning that we're only gonna take that proportionality. Okay, so that is the proportionality we're gonna use. Where there is LK, we're gonna put 12. We want KS is equals to, what is KN? We can replace KN by what? 4 over 3 SM, right? Because we are given this statement here and we can solve for KN. So it's 4 over 3 SM all divided by what? By SM. Okay, so now 4 over 3, if I multiply both sides by 3 over 3, then this 3 and 3 will cancel and we'll be left with 4 SM. So it will be 12 over KS is equals to 4 SM, right? All divided by 3 SM, right? SM and SM will cancel. Then when we cross multiply, it will be 4 multiplied by KS. It will be what? 4 KS is equals to 3 multiplied by 12. Okay, to solve for KS, we divide by 4, we divide by 4. All right, this cancel this. Then KS will be equals to 3 times 12, which is 36, divided by 4. It will give us what? 9 units. So that's basically how we solve that question. And don't forget, we just use the previous question because we have proven that it's similar. You can now move to what? To proportionality. That's what you have to be thinking of when you are solving similarity to proportionality questions. Okay, let's now move to 11.2.4. All right, 11.2.4, it says, if it is further given that NL, let's go to our diagram and represent this. NL, which is the bigger side there, NL in black, is what? Is 16 units, 16 units, okay? And also what? And LS, we are also given that LS, which is this one, this side. LS, let me use a different color for this. LS is what? It is 13 units. 13 units. This one must be in black. Let's just say 16 units here. And KN, let's go and check KN. KN is on the other side. It's this one. Is what? Is 8 units. Then determine with reasons LT. Okay, so they want this portion there, LT, this one in yellow. Let me just show you. LT is this one in yellow and black, LT. So they are saying determine with the reasons LT. LT. Okay, so basically they gave you the sides, right? And now you have to determine your LT. How much is it? They just give you LN, the whole of it is equals to 16 units. Okay, and they gave you this other one, this side, and they said is what is 13 units. Now they want you to calculate your what, your LT, right? Okay, so to solve this, basically you can just check where is my LT, right? My LT is in a specific triangle, and whatever dimension that I've been given here, can you see the dimension we've been given? It's actually in this triangle that actually have one line that is parallel to the other side, right? So there's a line drawn in that triangle parallel to one side of a triangle. Then we know that this is what? Proportionality theorem. We can use proportionality theorem to solve this, right? Because this triangle, this line drawn parallel to one side of a triangle, we know that it will divide the other side in the same proportion, meaning that we can now go and make proportion. We want LT, we're gonna say LT, which is this one, right? LT all divided by, we are given the bigger one, ln, right? Ln will be equals to what? Will be equals to ls. On this side it will be ls over the bigger one, which is what? Which is lm. Okay, let's go and substitute what we have. We are given ln, which is 16, right? So this is 16. Do we have ls? We are also given ls, which is 13. But we don't have lm. Can you see? We don't have this bigger one, right? Lm. But we are given kn, which is 8. So in maths, they don't just give you anything, right? They actually want you to use it in order to solve the other things. Okay, but you have to use relational understanding approach now. How can we get, because now we just need lm, right, in order to solve for lt, and we say this is from what? Proportionality theorem, right? We can also show the line that are parallel because mn is parallel to sk. Okay, so I forgot the reason there, right? So we just made proportion because we have a triangle like this where one line is parallel to the side. So we said this this side here over the bigger one will be equals to this side over the bigger one. So that's basically what we did. Okay, so now let's continue, and we've just substituted whatever we're given, but the problem is now we don't have lm. So to get lm, we need to get sm. Can you see? We need sm to get lm, because lm is equals to what? Is equals to ls plus sm. We are given ls, which is 13 units, but we don't know sm, right? But from the previous statement, that is why when you are solving Euclidean geometry, you have to be relating with the previous question, with the previous statement given. From the previous statement, we are given that 3kn is equals to what? 4sm. Using that statement, we can now solve for sm. Why? Because we are given kn, which is what? Which is 8 units. Can you see? So they didn't just give you this kn. They wanted you to use it in order to solve for the other sm, right? So where there is kn, we're gonna substitute with what? We're gonna substitute with 8, right? Because we are given it's equals to 8 units, and we go and solve for what? For sm. So we divide by 4 both sides, divide by 4, then 4 and 4 cancel, then sm, it will be equals to 3. 8 divided by 4 is 2, then 3 times 2 is going to be equals to what? 6 units. Okay, so sm now is what? Is 6 units. Now it's easy. We say lm will be 13 plus 6, right? So 13 plus 6 is going to give us what? 19 units. Okay, so that's basically what they wanted you to do there. Then we can now come and replace our lm by what? By 19. Okay, and cross multiply and solve for what? For lt that they need. So lt will be equals to 16 times 13 divided by what? Divided by 19. Okay, 16 times 13 is 208, divided by 19, it will give us 10.95 units. That is our what? That is our LT. Otherwise, great talk. Thank you very much for watching. We were doing Euclidean geometry. Proportionality theorem was incorporated. Moving from proportionality to moving from similarity to proportion was also incorporated. Make sure that you also check out some of our videos that are appearing on your screen now for further clarity. Okay. Thank you very much for watching. That's all for me, and goodbye.